Indiana Public Media Met Studio on the campus of Indiana University, this is The State of Inquiry, an audio and video podcast series of expert-led conversations highlighting the impact of IU research. In this season, Dr. Richard Carpenter guides us through Hope in Progress, Understanding Cancer Research, a 6-episode season of The State of Inquiry, speaking with experts, innovators, and everyday people reshaping what we know and how we live. Dr. Richard Carpenter is an assistant professor in the Department of Biochemistry and Molecular Biology at the Indiana University School of Medicine, Bloomington. His research focuses on molecular signaling and the cellular mechanisms that drive cancer development and progression. I'm Alex Chambers. This is episode 3 of 6 of Hope in Progress, Understanding Cancer Research.
All right, so we're starting the podcast today, so I'd like to welcome our guest. Dana Cattani is here with us, a patient advocate, so we'll talk a little bit about her background in a moment, as well as Dr. Patricia Silveyra, who's a faculty here at IU, and we'll get into a lot of her work as well. So I want to actually start with Dana. So Dana, you're a cancer patient advocate, so maybe you can talk to us a little bit about how you became a patient advocate.
So there's no formal training program that I went through. I am primarily an advocate because I didn't die and because I have continued to maintain connections within the cancer patient community. I was diagnosed with advanced endometrial cancer in 2012 and had a year of intensive therapy, including multiple abdominal surgeries and chemotherapy and radiation. And then as I met other people who were starting out on the journey after I had started, it just is very natural to talk about your experience with providers, with facilities, with treatments. So I became sort of informally involved in that. I also had the great good fortune of being diagnosed at a time that a gynecologic cancer support group was being formed in Bloomington, Indiana, and so I was interacting regularly with patients. And together, we decided that we wanted to lobby for some changes and improvements in the kinds of support services that were available in our community. And that really launched us into a series of conversations with foundation people and hospital administrators and researchers, and ultimately broader audiences.
Yeah. So we originally met through the cancer support community group that's here in town. So I do believe they and a couple of the other organizations do offer like some formal, position of advocacy programs. But so and I was going to mention the support group because I think you brought a couple of the support group to come and have a tour of my lab, which was very fun. So how long have you been doing the support group? Because I think, are you leading this now, I believe?
I help to facilitate it. I do a lot of the logistics. The support group began with 6, maybe 7 people, and because many of our members have had advanced ovarian cancers, for example, we have lost a number of people, and new people keep being diagnosed, so there's been some turnover. But there are, I think, 4 of us who were in the original group who still participate. Mm-hmm. And I made an active decision to continue to attend this group even when I felt that I was no longer needing the support as much, because it was clear to me that some of the newer people needed support. And it's very powerful when people who are in active treatment can talk to someone who is on the other side of treatment and is remaking a life. Right.
So for the people who maybe are not as familiar, so what technically is a patient advocate? Maybe you can talk a bit about what that is and maybe some of the activities. I know you mentioned a few of them now already, but what is the role of that in the larger scheme of the cancer treatment perspective and after treatment?
Advocacy gets a lot of play in conversations about cancer, and it begins with the patient. Patients often need to advocate for themselves by asking questions and clarifying and asserting their role in the decision-making process. That's a really hard thing to do if you are nauseated and weak and discouraged and just not feeling, and foggy, mentally foggy. Yep. So it's really helpful to have somebody who can do that role for you, and oftentimes that will be a family member or a close friend or someone who maybe can attend appointments, take notes, ask follow-up questions, that sort of thing. Beyond that, an advocate is somebody who has some experience, interest, or knowledge, who is willing to provide some kind of support. And the work that happens at Cancer Support Community of South Central Indiana is the work of advocating for people to have better access to support services while they are in treatment and beyond, and also for caregivers to have access to those kinds of treatments. So it includes mental health, it includes exercise, nutrition, social events, educational programming, all sorts of things. The broader advocacy work that I have been able to do has been speaking to larger groups about the patient experience. Patient experience is sometimes not centered, especially in the world of research, or even certainly in the world of the economics of cancer.
Yep.
The patient experience is not the focus.
Yep.
So people who are able to speak to broader audiences about needs, about gaps, and about what it feels like to be on the other side of the gown.
Yeah.
I think add a lot of value in conferences and gatherings anywhere. And also, I think, can be very powerful voices in meetings with administrators, finance people, and program planners.
Yeah, so I'm glad you mentioned that last part, because I think from the research side, we typically interact a lot with patient advocates when they're sort of lobbying for increases in funding or maintaining funding, perhaps maybe what's happening today. So these are all like super important roles, and very, very glad to have you doing those things. So I want to talk a little bit more about Dr. Patricia Silveyra's background. So you're currently, so maybe you can tell us what your current position is, and then we'll go a little bit backwards from there.
Yeah, I'm a full professor and the chair of the Department of Environmental and Occupational Health at the School of Public Health, Bloomington, at Indiana University.
Right. Now, you're originally from Argentina, I understand, right?
Yes.
And so did you do your graduate training there as well?
Yes.
You did. Okay.
I did.
So what was that like, and what is the sort of the scientific infrastructure like in Argentina?
Yeah, Argentina has a lot of support from the government for training, and our education is free. That kind of changes throughout times, depending on who's in charge right now. There's a big crisis, and our scientists are suffering a lot. But when I was a student, I had a scholarship from the government that allowed me to work in the lab while I was doing my doctorate work. Prior to the doctorate, we don't have bachelor's degrees like you guys have here. Mm-hmm. We have something called a licenciatura, which is a mix between a bachelor's and a master's. So you have to do a thesis or a course that is similar to a thesis, and it takes on average 6 to 7 years from the moment you start after high school.
Gotcha.
So I did that in molecular biology and biotechnology, and I specialized in mechanisms, intracellular mechanisms that regulate gene expression. And then for my doctorate, I went to work in an institute that was founded by one of a prior Nobel laureates from my country that was an expert in endocrine regulation of diabetes. That was his Nobel work.
Okay. Mm-hmm.
But basically my lab was a legacy lab from that type of work. So I work with hormones and how they regulate different processes. The lab had a lot of lines, including ovarian cancer. Yeah, some of them were more related to fertility, but my specific thesis was related to how hormones regulate appetite. So I work a lot with the brain.
Today,
yeah, it was definitely not what I do right now directly, but I do still work with hormones.
Right.
So when I finished my doctorate, was in the last year, I got an opportunity to come to the U.S. through a scholarship of an organization called Rotary International. They run programs all over the world, and one of the programs is called an ambassadorial scholarship. So you go to another country and you serve as an ambassador of your country while you either take a course or do a year of college, or in my case, I did a research project. So it's a bit of a long story, but I ended up in Hershey, Pennsylvania, because that was the club that sponsored me, along with my club in Buenos Aires.
Okay.
So I landed there, and I work at the Penn State Hershey Medical Center, which is the College of Medicine of Penn State, which is 2 hours away of Penn State, but that was a medical school. So the lab that I initially started working on was a diabetes lab. And I worked there for about 3 months, and it wasn't really what I wanted, but I still had the scholarship. So I was basically a free postdoc for anyone to take. And,
that's valuable.
And there was, I started interviewing people before going back to my country, and a laboratory that did a regulation of gene expression in the lung in premature lung diseases. That lab I really liked, so I started working there. So I worked there for about 3 years. And in that process, I basically brought all my knowledge of hormone regulation, endocrinology. So I started paying more attention at diseases that affect men and women differently, which was a very understudied area. And that became my area of research. So, in a few years later, I was able to get a green card. And then I applied for a grant from NIH. I got what's called a K Award. That allowed me to start my career, and then I became an expert on sex-specific diseases in the lung and how hormones regulate them. So moving forward, I worked for Penn State for 5 years as a faculty member. Then I worked for the University of North Carolina, Chapel Hill for 2 years as a faculty member. And since 2021, I am at IU. And I haven't been chair all this time, but I've been chair for the past 3.5 years. But basically that's what I do. My research lab studies sex differences in lung disease, including asthma, lung cancer, COPD.
I see, yeah. So you had quite a long time in Hershey. I assume you went to the Hershey Museum and did the little factory tour and got the free chocolate while you were there.
Yes, a lot of times. Especially when we would invite, as faculty, we always host researchers come give a talk or faculty candidates. So getting in the ride with them was
that's
one
a good
of my activities that we would do.
That's a great activity. Okay, so just a little bit back to your time in Argentina. So the first real exposure to research, was that during that sort of undergrad, master's combined time? Is that sort of where you fell in love with that process?
I went to a high school that is sponsored by the University of Buenos Aires. So basically, my professors in high school were faculty members in the university. So I had that privilege because you had to get selected to go to the school. Again, it's a free school, like many, everything public there. But I had a professor in biology when I was like halfway through high school. And he was a grad student, actually. So he on the weekends would take us to his lab, and he would make us how they grow bacteria and do a lot of cloning. And at that time, they were cloning the sheep. So this is 96. I was like third year high school. So that's basically when I started falling in love with it. But then there were scientists that would host science fairs, or they would open the doors of the labs, and I always showed up for those things. And I remember when I decided I was going to be a scientist, I went to one of those fairs, and there was a professor. She studied plants and how, the different genes in plants regulated how plants process nutrients. And she said, thanks to science, I lived in 4 different countries, and I work with people from all over the world. And, when you are a scientist, you basically can live anywhere, and you're always going to be surrounded by people who are different than you. And when she said that, I was like, this is the career I need to go for. Because I was thinking about, something that had to do with the world or traveling or just meeting more people. I had never left the country. But to me, that was like the best motivation I could have. And it's just, you never know what's going to motivate you. But then science was my call.
Oh, that's a great backstory, actually. It's actually, and the whole setup there is very unique. I feel like we don't really have a similar type of experience here where high school students really get exposed to much research. We occasionally will have high school students, email us to be like, can we work in your lab for the summer or something? But that seems like a very formalized process or program to have that going.
Yeah, it does start. There's different science festivals that allow for that interaction. And actually, we do have science fests here. But we also have a different science fest that is run in February at Girls Inc. of Monroe County.
Mm-hmm.
And that was a project that started between my lab and Girls Inc. We started it, and now it became a thing. So they have a theme every year. And we ran it on February on the International Day of Women and Girls in Science. So yeah, those things happen. And I do have a high school student that works in my lab.
Yeah, I did too, actually. Yeah.
You're paying it forward.
Yeah, that's right. Yeah.
Well, you see yourself in these trainees, and and then no matter their career future, it's good to have the exposure.
It's wonderful.
Yeah, that's right. I feel like a lot of the high school students and undergrads that work in my lab, they really find out if they want to be a scientist or not by this experience.
Mm-hmm.
It's usually not so much like putting them on this career path. A lot of times, most of them end up doing, if they stay in science, they end up doing something completely different. Like you, right? You were working on hormones, and then you're on lung physiology, right?
Mm-hmm.
But it's a lot of times it's more of like, do I really like doing this or not, or or as you're in your case, just fall in love with it, right?
Right.
Yeah. Okay, so coming to a little bit closer today, so you one of the reasons I wanted you to join our podcast series was you sort of have this interesting scientific setup where you really study lung physiology, but that lung physiology study sort of applies to multiple disease settings. One of them, of course, is cancer, and so we'll talk a little bit about that at some point. So how would you characterize, sort of the base function of your lab as it relates to that?
Yeah, so I think the central theme in my lab is lung inflammation. And inflammation is a very loaded word.
Mm-hmm.
It involves secretion of proteins. It involves different cells being involved, processes, genes activated, genes unregulated, and inflammation can lead to cancer. It can be important to fight cancer. It's a key mechanism that initiates and makes worse several diseases. So asthma is an inflammatory lung disease. COPD is an inflammatory lung disease. When you are infected with a virus, you develop inflammation. So we study specifically how inflammation develops in males and in females, biologically speaking, in terms of XY, right? But we also look at how when hormones fluctuate, for example, females throughout their menstrual cycle, or when they undergo menopause, or when they undergo puberty, how are these hormones controlling these mechanisms? So in science in general, we take a very conservative approach. We think a mechanism is from A to B, right? And then years pass, and then a drug goes into the market, and half of the population maybe doesn't work, right? Or like women don't respond as well as men, or the other way around, right? So we're trying to get towards personalized medicine by studying these biological components of sex that can influence the mechanisms that underlie disease.
Right. So, okay. Yeah. So I do want to actually touch a bit more on the sex differences, because I know it's a huge part of your thing. So before that, though, I want to touch a bit more on the inflammation part. So can you describe, what you mean by inflammation, particularly as it relates to the lung?
Yeah. So your lung is a system that puts you in contact with the environment, right? So when you're breathing, things can get through your lung to your blood very fast. You think that things can get to your body if you eat them. Actually, if you really want something to go to your blood fast, you should smoke it, basically, right? So, and that's a problem, because we're constantly breathing things that are toxic, that are harmful, and we don't have much control of what we're breathing. So our body has developed multiple forms to protect us. So the very easy one and fast one that it has is called the innate immunity. And that is mediated by a few cells, particularly the most common ones that we have are macrophages. These cells, they don't specialize to just find a particular bacteria, a particular virus. They just will go for something that looks weird, right? So they have things in their membrane that are going to allow them to recognize structures or patterns that are different. And then when that happens, they get activated, and they start secreting signals for other cells to come through the lung. So then some of the cells that are coming to the lung are secreting stuff. Some other cells are just dividing a lot, and then you get like swelling. So it's a very complicated process, but it basically is a system that the body has to protect by setting up alarms. That's what I would say is inflammation.
Right. Yeah, and then so and as you're talking about, so the our lungs is one of the organs where we do have a lot of exposure to the environment. So if you're breathing, in high pollution areas, any of these types of things. So what kind of environmental exposures do you typically study in your lab?
Yeah, so we study some of the most common components of smog. Smog is made of two components. One is ozone, and the other one is particulate matter. So if you ever see, the clouds of smog, you'll see like a little bit of darkness. That's usually the particulate matter. The ozone, you can't really see it, you can't really smell it, but the ozone is very irritant to your lungs. So we pay very close attention to it because that's one of the elements of pollution that is going to continue to inflame and harm the lung even after you stop being exposed. Those are like the two main ones. There's other components of the environment that I wish I could study better. For example, radon is a very big one, right? Radon is also a gas. It's invisible. You can't smell it. But it's, especially here in Indiana, in other areas of the country, we are exposed to very high levels above what we should be exposed to. And that, I think I heard there was a study that checked in some areas of Indiana is the equivalent of having like 5 CT scans a year. Like that's crazy how much radon people are exposed to. Radon is one of the top causes of lung cancer. And it's in the basement. You have to measure for it. You have to mitigate it. Otherwise, there's no way it's there. And then more recently, with changes in the environment, we've been experimenting some more wildfires. So wildfires cause a lot of dust in the air and, just particles that travel very long distances. And then they reach you even if you're not where the fire is happening. So we are developing new models to study different types of wildfires. Because it really depends on where they happen, what else is in the environment, what kind of wood is being burned. So all these toxins that could travel long distances. And then the last thing we study is not necessarily an air pollutant per se, as in like it's generated by a factory or things like that, but it's, it's vaping. So, vaping is very common now. It started as an alternative to smoking, and it's very poorly studied what happens. So what we have a lot is knowledge of what you can buy in the store, right? That's regulated, and, as much as we can, we regulate that. But then when you take that fluid and you put it in a pot and you heat it at a very high temperature, a lot of these chemicals get converted to new chemicals. And we have found that many of those chemicals are potential carcinogens. And not only that, the plastics that are used to heat this and the coils, they can also release phthalates. They can also release heavy metals that are going to go in the lung. And as I said earlier, the lung is a very easy entrance to your blood and your body and everywhere else.
Okay, I was going to bring up the vaping thing because that is obviously very present now in modern day. And when I teach cancer, sort of an intro to cancer biology class to freshmen, I always get the question of, is vaping better than cigarettes, or is it even going to a risk factor for developing lung cancer? So what are you actually finding as it relates to that? So I have read just as a preface that even if there's less carcinogenic, I think even some of the actual just smoking can alter the lung physiology to some degree. But what are you finding in your studies?
Yeah, we're finding many things. I can tell you that, it's a complicated question because when people smoke cigarettes, there's a lot of rules, and there's also the smell. So there are many factors that are going to make probably people smoke less frequently than vaping. So just the comparison, do you vape versus do you smoke, is very hard to make. What we know is that people vape more often. They don't really think about vaping because it's like vape in and out. They don't have the process of starting a cigarette or finishing it. So the dosing is very hard to account for. Now, when we do control dosing and we expose cells and when we expose mice, we see a few things. So in mice, some of the most, I would say, striking things that we found, we went for nuclear receptors in the lung. These are receptors that, just to put it in like easy words, these are proteins that are in the cell that can go to the nucleus of the cell where the genes are. So these are very easy proteins that are going to help activate expression of genes. So better than other proteins. So they don't need like a complicated mechanism. So we found multiple nuclear receptors that were differentially expressed, which may mean that there are multiple genes being affected. Now we're studying what those genes are, and of course we're going for the cancer genes first because that's what we believe is happening, as similar to cigarette smoke. Now, in terms of the cells, we see inflammation. We see inflammation not just with the nicotine that is present. We see a bit of effect of nicotine, but we just see an effect of just putting the vape fluid. Like you may not even have a flavor or a nicotine on it. You just may be vaping that fluid that is in all of them. It's almost like a
placebo or something, right?
Right, but that triggers inflammation in itself and changes in gene expression. So what we have is very preliminary because we're getting started. It's very hard to keep up with the market because by the time we set up an experiment and we say, okay, this is the product we're studying, you go to the vaping shop and there's like 1,000 more. And we want to, of course, we want to be in communication with the community. We want to know what people are using. We want to know what are the trends. It's really, really hard to keep up with. But when I study a vape fluid, I go to the store here and I purchase it here and then I use it in our experiment. I don't use something that is genetic because we want to be as close as possible to like our own community. And then we have some studies in collaboration with women who become pregnant and they switch from cigarette to vape. And there are a few products that I don't want to call them like recommended, but it's like there's like a list of, okay, these are the ones that if you're going to do that, these are the ones you're going to use. So a collaborator of mine surveyed the population in Indianapolis and found out what was the top used. So now we're using that one in two ways. One is to study the effects in pregnancy and the mom and the pups. But we also vape towels, and then we put those towels along the mice. So when you smoke or when you vape, the vapor that's formed around can land into this table, can land into this carpet, can land into the couch where there's a toddler walking around and touching it. And even in those surfaces, we have found compounds that could then affect by either dermal exposure or inhaled exposure. So that is what we call the third-hand exposure, right? Yeah. So, there's a lot that we're doing. A lot of it is exploratory because we're trying to cover as many dangers as possible before they become a problem. But what I tell people and what I tell students when they ask me is there's not enough time of us being in knowledge of these products to make a proper recommendation. And so far, the preliminary data is telling us that this is not very safe. I cannot tell you if it's more or less dangerous than a cigarette, and the comparison is hard to make based on the dosing, but I can tell you that from everything that I've looked at, I cannot tell you that this is a safe product, so if you can avoid it, avoid it.
Right. And I think it's probably even a little bit too early to have sort of long-term epidemiology data yet to know what's sort of the long-term impact that we have, decades and decades of smoking results to show that that's dangerous. But I don't think we quite have accumulation of data epidemiologically to support that yet. I assume that's the case.
We don't. We do have some data showing that people who have switched from smoking to vaping, the cancer rate has lowered a little bit. But people who have switched but kept both, right? If you smoke and vape, actually the risk of lung cancer increased like 9 times. So, if you're going to switch, just switch or stay, right? Based on that one study, right? It's just one study in one population, and we don't even know what's in the pollution that they're breathing. We don't know any underlying diseases they had. It's, when people want to make like straight associations between two things in science, I have to warn them that, when you look at this big piece of data, you have to consider that there may be something else mediating or modulating what you're observing.
Right. Who funds this kind of research?
Who funds this kind of research?
And who might object?
What a loaded question. So typically the funding comes from the National Institutes of Health.
Even this year?
Not this year. But there are, states have different sorts of funding. Like California has a big tobacco research program that also touches into vaping. I only know about this because I am a reviewer for some of these things. There are foundations. There are associations like American Thoracic Society, and then there are associations, internationally wise. This year, the funding is a little complicated, as you know, but, some programs have stopped, some programs have been on hold, some programs, we don't know what's going to happen, right? It's not that everything, like, all of a sudden stopped being funded. It's just like navigating the system became a little bit more complicated, but I couldn't give you right now a prediction of what's going to happen. I can tell you typically, and up until the time that I started doing this research, it would be the National Institute of Environmental Health Sciences that had like a tobacco research program. Some of those programs have sunsetted, some of the programs have been merged with others. So right now, I can't speak for the NIH on what's going on inside because I don't know. Mm-hmm. But typically the government used to play a very big role on that, and even the EPA. I hope that answers your question. Not really much of an answer.
But
going back to like the association studies, and there are certain cases in which we get information very fast. Like when the vaping epidemic became a big problem. I don't know if you remember, a lot of people dying from vaping. It was a specific component, the vitamin E, that was added to just to make more smoke, right? Because it's fun and it looks cool, right? And then very fast we learn about these very young people having a phenotype that looked like an older person with COPD. And even a lot of deaths, unnecessary deaths happen because, we don't conduct the proper research. This is a typical example of, what we put in is not dangerous, but then after being heated up, it gets converted to this very dangerous chemical.
Right. So regarding the vaping, I've interacted with a lot of patient advocates and on that side of things, and I've definitely heard more than a few of them mention after a cancer diagnosis that they will stop smoking but switch to vaping. So I'm wondering, actually, if Dana, if you have interacted with people who've done this in the patient advocacy side, because it seems, I think they come into this thinking, we've got a safe alternative here, but it seems like maybe that's not the case.
That's generally, I think, what people think, that the marketing around vaping as a safe alternative or a way to stop smoking has certainly gotten through, and people do make that change. It's fascinating to me to hear you talk about the combined effects of both smoking and vaping, and that certainly suggests to me that there's some inherent problems that we haven't fully fleshed out.
Right.
Well, you have to keep in mind everything else I said, but also if a survey says, have you switched to vaping, but you don't really ask, what are you vaping? How often are you vaping? Where are you buying your product? This may be something related to a particular group of chemicals that are in the vaping products that these people are using. Not necessarily that vaping and smoking is bad, right? So it's very easy to make that conclusion. I don't want to rule out vaping as a safer alternative to smoking because I don't have enough data. I'm just, from what I see in my research and what I read, if there are a better option to quit, but you're going to quit, then use a different option.
I think a broader issue with cancer patients, and it doesn't only apply to smoking and vaping, is when you're under stress, when you're experiencing great anxiety, what do you reach for? And what are you willing to give up when you're already giving up so many other things? And I think that's a very fine line that
Yep.
I generally don't try to tell people what they.
Yes. Yeah.
I don't try to get into that. Alcohol is an issue.
Yep.
Junk food is an issue. Exploring the dark side of the internet about your diagnosis is an issue. I mean, all of these things are kind of complications, and it's hard for people under duress and whose lives have been upended to give up some familiar comforts.
Yeah, I mean, that's exactly the reasons that people tell me why either, they've been diagnosed with lung cancer and won't stop smoking right away or take some time or even don't stop at all. It is exactly for that reason. Yeah. Okay, I think we're going to take a short break here, and then when we come back, we're going to talk to Dr. Silveyra about some of her work on the sex differences and then maybe some of her work on the cancer side of things. Okay, welcome back. We're here again with Dana Cattani and Dr. Patricia Silveyra talking about lung physiology, of all things, and its relation to cancer. So, Dr. Silveyra, I know you do a lot of work on sex differences for lung physiology and even some other things. So what can you tell us a little bit about how the lung physiology is different between males and females, and sort of what are some of the molecular underpinnings of that?
Yeah, big questions.
Yeah, big
today.
questions.
Yeah, well, there are many aspects of sex that can influence how our lungs function. And I wanted to separate the definition of sex and gender, if I may, because, in science, we tend to use them. Okay, well, I don't want to use the same word a lot of times, so then I'm just going to use gender instead of sex. And gender and sex are very different things. Sex has to do with the biology, has to do with anything in the X chromosome, the Y chromosome, the hormones, the anatomy, the physiology, whereas gender has to do with where we live, what we define as a woman or a man. And gender may be different in different countries, different cultures. But gender matters because if I am a female or a woman in a particular country that all women are at home cooking all day in front of a stove, inhaling particles, my lungs are going to be affected a different way than the male's lungs. And I may develop more COPD, not necessarily because the biology is priming me to it, it's because I'm exposed to this particular danger. Same with firefighters, same with people who work in coal mines, right? So when we look at epidemiology of diseases, we may easily conclude that it's a biological aspect, but it may be a combination of a gender and a biological aspect. So, and then, this can get as complicated as you want to see it, right? So what my lab does, we study the hormonal and chromosomal components that influence the inflammation processes. And we do that in a bunch of contexts. We do it in the context of air pollution, in asthma development, and in lung cancer. And so what we found in general is that females who have high levels of estrogen tend to develop stronger inflammatory responses to certain challenges. For example, an early study we did, we exposed male and female mice to ozone at a control level for the same amount of time. And what we found is that the females were having more inflammation, they were doing more poorly, and there were more genes that were related to this combination between that innate immunity I talked before to the adaptive immunity, which is when your cells become specialized and you may develop a more chronic disease. Those were more activated in the females. And then we did this experiment where we removed the ovaries of the females and then we gave them estrogen back. And we found that when the ovaries were gone, a lot of these inflammatory, very crazy triggers weren't happening as much. And then we gave the estrogen back and the response was back to basically like the regular, the control females. Now we tried to do the same in the males, and we said, okay, if estrogen's the bad guy, right, let's put it in the males. So we removed the gonads of the males, and gonads are like the testes or the ovaries, right? And something super interesting happened. We removed the male gonads, and all the males became super pro-inflammatory. Like they responded to ozone even worse than the females.
And that's with the estrogen supplementation?
Without. Right,
without. Oh.
So that
So
we learned by trying to study estrogen, we learned that actually maybe testosterone is protecting the males. Right? When we gave them the estrogen, in some processes and some genes, we saw the same as in the females. In others, we saw the exact opposite effect. So that is what led us to believe, okay, there's a combination here. So it's not just the hormone. It matters what hormone, but it also matters the composition of the chromosomes of the cells. So we went ahead and we used a different mouse model. This animal model is called the 4 core genotypes. This animal model has a mutation. It's a transgenic mouse that basically removes in the Y chromosome for the males. There's a little piece of the DNA that when that is activated, the males become males in the secondary sexual character. So basically they develop testes and they secrete testosterone. If we remove that from that chromosome, now the animal's going to become, it's going to still have XY, right, and all the other parts of the Y chromosome, but it doesn't have testes, actually developing ovaries. So by default, we're all females without that, right? So whoever, I know who they did. There's a professor in UCLA who created this mouse, and they put this region now in a different chromosome, chromosome 3. So now you can have the mouse without that region that technically will have ovaries, but now if that has that chromosome 3 with that region back, it becomes a male again. So that allows us to have 4 kinds of mice. That's why it's called the 4 core genotypes. We have female mice that have XX and ovaries. We have animals that are XY and ovaries, and then we have XY males with testes, and then we have XX that have testes because they have that chromosome 3. Right? So what can we do with this? If we put this to a toxin or a challenge or to develop asthma or to develop lung cancer, now we know if there's a difference, if it comes from the hormone or if it comes from the chromosome or if both are needed. So in this is like asthma, we found that for the inflammation in the lung, mostly is the hormone, the one that is driving most of the phenotypes. For like the lung function changes, asthma is a disease where you have a lot of mucus and inflammation, but your airway is kind of constricted. So, and that's like a muscular effect of your lungs. That effect needs both. Right? So we're learning that the different features of diseases may be regulated just by hormones or by a combination of both or just by certain genes that are in the chromosomes. So when we find the chromosomal effect, then we can go and study each gene in particular.
So down the road, might that suggest that a woman who is menstruating would have a different kind of treatment for lung cancer than a woman who is, say, postmenopausal? Or that a woman and a man, both diagnosed with the same staging of lung cancer, might have different medications or different treatments?
I have so many answers to that question. All right, I'm going to start with the differences in lung cancer treatment responses. And we know that for some of them, the females are poorer responders. And we know that estrogen is a big culprit for that. There's a mechanism that we're studying that involves a protein that mediates all of these parts of the story that actually Richard knows about because my postdoc's using some of his machines to investigate this with these mice. For sure, it matters if you're a male or a female. We don't know if it matters if you're in reproductive stage or not because most people diagnosed with lung cancer are in the older side, so they're like post-menopause. However, we're seeing a big trend of younger women that are non-smokers that are developing lung cancer. This is something that's in the past few years has become a big problem, and we're raising awareness of this. We believe it's related to accumulation of exposures to different air pollution. And these people don't smoke. There's this big stigma about you smoke, you're going to get lung cancer, and then it's your fault, right? And, first of all, smoking is an addiction, and nobody should be blamed for developing a disease. But second, it may not be the only thing that causes cancer, and definitely not the only thing that we're studying. Now, to answer your question about the woman menstruating, I can tell you diseases like asthma. I can give you 3 examples of why hormones could make asthma worse. One is women who have asthma and they are in their menstrual cycle. About 40 to 60% of women have what is called premenstrual asthma, which is right before their period, or the symptoms go like 3-5 times higher. They get more hospitalized, they use more the inhaler, they get more intubated, they visit the ER more.
I had no idea.
I know, right? Yeah, but ask
any
woman, right?
To the estrogen spike, though, would be the thing, right?
Yeah, we think it's because of that's one of the reasons we did all those experiments. Yeah. The other thing is when women become pregnant, it can go anywhere. If a woman has asthma and becomes pregnant, it can resolve their asthma, it can make their asthma worse, or nothing can happen. And that is called the 30% rule. It's actually kind of, those studies were conducted in a way that they're like, okay, pregnant, non-pregnant, right? And that during pregnancy, hormones are very different throughout the 9 months. There's a lot of things to separate and study individually. So we're actually starting to look into that now. And the other one is menopause. So when a woman has asthma and it undergoes menopause, there's a very big chance, I forgot the percentage, but it's very high, that it's going to resolve their asthma. Right? Resolve it, yeah. A lot of them resolve it, except in cases where the woman is taking hormone replacement therapy.
I was just going to ask you about that.
Right. Actually, the risk kind of increases a little bit, right? If it is estrogen, progesterone, or both. And if a woman, let's say, had breast cancer and had to take anti-estrogen treatment, their asthma risk after menopause decreases.
I'm sorry, can you say that again?
Their asthma risk after menopause decreases. So it seems like the exposure to hormones, either estrogen, progesterone, or both, makes your asthma worse. And then, this menopause transition, unless you're receiving hormone replacement therapy, again, these are all associations of numbers and people, yes, no, right? We don't know what else is in their lives. We don't know what they're eating. We don't know what they're breathing. But for, putting all the data together, these are, thousands and thousands of patients in asthma programs. We're seeing this. So we want to understand what the hormone does before we tell everybody stop taking hormone replacement therapy, because hormone replacement therapy is very good for many other functions of the body. So, but if you have asthma, you may want to consider taking a closer look at how you're using it, what combination, what dosage, right? And for that, we need research. We need information. And we also need to know what's going on, because you may still be taking the hormone, and whatever is a side effect of this hormone that's causing your asthma continue or get worse or whatever, we can treat that if we know what's going on.
So let me cycle back to cancer patients. So I was on an estrogen suppressant for 10 years after my treatments ended. Does that make me, or does that make one who does this, is that person less prone to inflammation?
Less prone to asthma in terms of, epidemiological studies have shown.
So asthma specifically, but not general inflammation.
I would bet that it's probably related to inflammation based on the information I have from my animal models. The data that I have seen is in women developing a disease or not. And the diagnosis of asthma is, do you use your inhaler 3 times a week? Or not? So asthma is a very loaded disease. I think I read once a paper that said it's 40 different diseases, right? Yep. I mean, people can have different types of asthma. We all call it asthma based on that definition, right? But if you have an asthma that is a particular type of inflammation, there are many what we call endotypes, then yes, it may be that estrogen is the one that is protecting you or making it worse.
So one of many sources of stress for cancer patients or survivors is knowing how the different medications that they take or do not take affect their chances of either a secondary or a recurrent cancer or other complications. And estrogen suppressants are certainly in that camp. They are often associated with loss of bone density, for example, which is increases the risk of breaking hip or something. But if they also offer some protective benefits in terms of inflammation, I don't know how to weigh those those benefits and costs?
Right. Not every tumor is going to respond to the hormone the same way, right? So, in this, you have to trust your physician, with the information that they have from the markers, and you're always going to have to weigh, risks and benefits. I think, the solution to this is to have more research to understand what's going on.
I was just going to say that.
To look beyond,
we need much more research faster.
Yes, absolutely. I mean, information is power. Like we can't predict things if we don't have information. So, for sure. I think, it's important that we discuss all these things, but it's also important to know that, when you have to make a decision, whether, you're going to maybe risk breaking your hip, what is the chance, right? What is the likelihood, right? It may happen, may not happen. So then look at the data and see what are the other factors that may play a role. And you may compensate that with your diet. You may compensate that with some other treatment that exists. I'm not a physician, so I'm not going to say anything.
From the patient's perspective, though, it feels like a very high-stakes poker game, and you can't know what's in the other player's hands.
Yeah.
And estrogen is also a protective cardiovascular side of things as well, and reducing risk. So it is like there's a trade-off, right? As we get into these ages, like there's trade-offs for a lot of these things.
And when you say to trust your doctor, I want to do that, but I have a lot of doctors, and they don't always agree on the costs and benefits of the medications that they recommend that I take or do not take. And I think that's a very common experience for cancer patients.
Yeah, I think we need to have more conversations.
I think some of it also too is I think doctors are not always keyed into cutting edge side of research just yet, and they're usually not making recommendations until things are really solid, right? That we know this is not going to be harmful to the patients, right? They always have that directive ahead of it. I want to circle back now to your cancer side of things, because you're also seeing some very interesting results, sex differences for lung cancer as well. So if you wouldn't mind elaborating a little bit on that for at least. I know you haven't published all of this stuff yet, so whatever you're comfortable with sharing, right?
Yeah, well, we have the data that we're learning from patients and the epi data, and the epi data is telling us women are, reaching out to the levels of males developing lung cancer, but they're also dying more, and these trends keep going up. So there's something going on that is. That wasn't happening before, right? Because it used to be a disease of males. It's a combination, how we diagnose, how often we diagnose. Maybe before we were missing all the females because we weren't looking at them. I think if I have to make a prediction based on my science, it's a combination of exposures. Women are exposed to multiple toxins throughout their lives that are going to cause inflammation in the lung. And that prolonged inflammation, along with the estrogen that we have found that it exacerbates some of those, is making some of these processes more prevalent. Women use a lot of cosmetics and hair products that, like we are learning that are not necessarily as good for you. So I think we're acquiring that information. So on the one side, we know that, and we know that there's a lot of estrogen involvement in the development of these tumors. Now, in terms of the mice, we've been trying to model this disease, and it's very hard to model lung cancer in mice. You can give a toxin, repeatedly, and then hope that the tumor happens. You can mutate something that is already mutated, right? So in our particular case, I used this mouse model to differentiate the hormone and the chromosome, and the model I used tends to make tumors worse in the males, actually. So I can't really use it too much to study the female cancer, but the females also develop tumors. So now we're looking into the internal biology of those tumors. There are certain features that tends to be the chromosomes. So, it's your genes. The X chromosome has a lot of information that we haven't really looked at. There's a group of studies that we do as scientists when we look at all genes from everything, right? We just take DNA and we look at everything, right? And for the longest time, we have excluded the sex chromosomes. Like we remove the X and the Y, or they're too complicated, right? Let's look at everything else. So we have a lot of information everywhere else, and now there's a big push to re-include those. But I can tell you the X chromosome is full of immune-related genes and a little regulators of gene expression called microRNAs. So every time we find something in the chromosomes, we're going for that. So right now, my model is not really very good to model female lung cancer,
Right.
which is why I haven't published much.
Yeah. Oh, no,
But what we're learning from the females or those who have either ovaries or XX chromosomes is that the responses or the development of the tumor and then some of the genes that are being expressed are very different. So hopefully in the next few months I'll have more information.
Yeah, that wasn't a comment on it, I think. Yeah, well, I didn't want you to talk about anything you weren't ready to disclose.
No, that's okay. I mean, I don't like to talk about things that are not ready.
Yeah, no, I get it. Yeah, and so so epidemiologically, we know lung cancer is the number one cause of cancer-related deaths for both men and women now. Even though that's not the most common cancer for either of them. Right? Breast is the most common for women, and prostate for men, but lung cancer is the number one cause of people dying from cancer at the moment. So it doesn't seem, at least from that, like it's for both sexes in that case.
Well, we see the trends, right?
Yes.
That they're growing. It's just if you project the slope, you see that the females are growing more than the males. Are also like both die less than before because there's more treatment, and the research has caught up a bit, and the decline in the deaths in the males is much steeper than the one in the females. Right?
I have a feeling those declines are probably smoking related or smoking cessation programs related, right?
Yeah, a bit of it is that. It's also the response to treatment. It's also how often people get access to care. Very, very loaded.
Do you find that men and women get access to care equally?
I think women are less likely to go to the doctor in terms of, just when they go, it's like they go when it's just much later. Like that's what I see in the research I read. I don't conduct that research. But they tend to be like putting it off more. Whereas I think males, not necessarily they go. I think is what we see is like the females in their life take them more, right? So it's funny because women tend to do these things. They care for others and they don't care for themselves. And I feel like everybody here knows someone who does that in their family, right?
It's interesting because I think often women access healthcare more through gynecologic exams, through pregnancy, through pediatricians, through women interact with the healthcare system quite a bit.
But that
doesn't
like when there's a cough or just like a mild, respiratory issue, which could be lung cancer, that's like gets to be brushed off more.
No one wants to find out.
Right. Well, it may be, maybe for the sociologist to investigate. That's right. But I can tell, going back to what you said, the top cancers, breast cancer and prostate cancer got a lot of attention. They got much more research. The lung cancer is severely underfunded. And they are, now easier to diagnose, to find a treatment, and the treatment is more available. With lung cancer, unfortunately, there's not a symptom. You're not going to say, oh, I have this, and then I have lung cancer. The only way to detect lung cancer is to actually scan your lungs. And we don't scan your lungs unless you have been a smoker for a very long time or a certain age. So there are people who are maybe just a bit of a cough, chronic cough, whatever, and then, or maybe there are people who just get in a car accident, they get a CT scan, they find the tumor, right? Like it's a secondary thing. Unfortunately, because we haven't had that attention and funding, we don't have a good biomarker to detect cancer early, and lung cancer is curable if it is detected early. So it's kind of this, give and take. So we are advocating a lot so people understand this is a big disease. This is something that requires research and you to pay attention. But it's a very big effort. Our cancer institute is doing really great with that.
Yeah, I think lung cancer is one of the most prominent cancers in terms of incidence and deaths without a good screening tool, right? Yeah, like you said, the only screening tool is basically a lung X-ray, but you only to qualify that you have to be a smoker for whatever. Right?
So it's not covered by insurance. It's not covered by government programs.
It is now, yeah. So there's actually patient advocates that work with every patient. So Indiana is very lucky that this year they launched a program thanks to a big donation. They have a mobile unit that goes around different towns in Indiana, and it has a scanner, so people can sign up to go. There's like a few criteria that they have to meet, and then they work that out with their insurance or other options. So they have screened many patients since it started in April this year.
Yeah.
Yeah.
Is it possible to qualify for a screen based on occupation?
I'm not aware of who makes the decision of who gets screened or not. I believe you should.
I mean, for instance, people who clean professionally are exposed to all kinds of fumes, and there are a variety of people who are professional cooks.
Or even if you live near a manufacturing plant, like all of these types of things.
You would be at increased risk, I would think.
Oh, absolutely.
Yep,
absolutely. Yeah, I am all for everybody getting screened. Yep. I think the guidelines that are put in place is a combination of, what you say, the physicians, the knowledge, the information that we have, but also, how much we advocate for these things. So the American Lung Association of Indiana is doing a great job at, looking at all this information. I just joined their board, so I'm learning more and more every day.
Excellent.
Yeah, so getting into this, bringing awareness, because in order to make these people qualify, we need data to support these recommendations, right? And to get the data, we need research. To get research, we need funding. So it's kind of like always going back to how much attention are we paying to what we should be paying attention. But you look at the trends, especially in our state, with the levels of radon that we have, with the levels of smoking that we have, with the little control on the smoking cessation programs that we have that are not accessible to everyone, and the patient education, right? Do you know what you should be looking for? Do you know that you're eligible for this? So all of that, is a combined effort. So we got to attack it at every front so that we can help people access the care that they deserve.
This is part of my journey as a patient advocate, was starting out and helping people to understand this is what a CT is going to be like, or this is what a PET scan is, or here's what you can expect with radiation, or here's how you manage nausea. But it has really now shifted toward how can we get the funding that we need to put these services, screens, and other things in place so that they are more effective and we can catch cancers sooner and treat them more effectively and have the research that we need, so we should know what kinds of medications we should be taking after treatment and what the pros and cons are.
Absolutely. And we are in a big crisis right now with that the trust in science in many parts of the population. So it's important that we stay together and continue the work.
I'll mention the lung mobile screening unit is run and sponsored by the IU Simon Cancer Research, Simon Comprehensive Cancer Center. So I do expect that over the next couple of years we should be getting some data about how effective that is managing some things now that it's been going starting earlier this year. So it's been a great conversation. We've learned a lot about estrogen. We've learned a lot about vaping. And some of the sex differences. So I'm really happy that you guys joined me for this. So thank you, Dana Cattani, for joining us.
My pleasure.
Yeah, and Dr. Patricia Silveyra for joining us and telling us about your work.
Thank you for having us.
Awesome. So we'll see you next time.
You've been listening to The State of Inquiry from IPM.org, recorded at the Indiana Public Media Met Studio on the campus of Indiana University. This has been episode 3 of 6 of Hope in Progress, Understanding Cancer Research, with guest host Dr. Richard Carpenter. The production team for this episode of The State of Inquiry includes Scott Carmichael, Nate Wrigley, and me, Alex Chambers. The director of content at Indiana Public Media and executive producer of The State of Inquiry is Eric Bolstridge. To offer feedback and ideas, to support our content and our mission, and to find more podcasts from Indiana Public Media, like my show, Nice Work, visit ipm.org. Copyright 2025, the Trustees of Indiana University. Thanks for listening.